Hey everybody, welcome to the part 2 video of section 10.2. In this video, there's a worksheet that you can find either online or available in class that has basically more problems that cover actually the material from 10.1 to 10.2 with a little bit of a little extra thing from 10.3. It's the only thing you'll see from 10.3 really. Um, And I don't want to spend too much time on stuff that's already been covered in the videos. This first problem here on the sheet is a bunch of matching of these terms, um, and these terms are ones that you saw in the first two sections, basically. Mostly, these are terms from section 10.2. Um, so I would invite you to try it out. Um, knowing these definitions is going to help you in being able to solve problems because problems you see will use these words and these terms, and knowing what they mean will help you figure them out. Um, Going towards the other problem types here. Problem one is the type that you saw a little bit on the last video, where you have to find the measures of each arc. Important to remember that the measure of the central angle helps you see the measure of the arc that it's opening up towards. So since that angle that I just highlighted is 45 degrees, that means that arc RS would also be 45 degrees. The fact that TS is the diameter is important because that tells you then that this angle, or this arc here, would have to have a measure of 180 minus 45, which is 135, because a semicircle has 180 degrees. So you could continue on with that problem if you wanted to. It's going to use, again, very, very similar ideas to what we had in our last video. And problem two is also like a problem that we saw in our last video, identifying things as major, minor, or semicircle arcs, and, finding the measures of different arcs. This part here itself is not really anything new, these first two problems. But if we flip to the back page, there will be some stuff that's a little bit new. Problem 3 is not new yet. That was the idea of arcs being congruent or not. Remember, congruent circles will lead to congruent arcs if the arcs are the same size. If your circles are not the same size, you can't have congruent arcs. Problem 4 is sort of new. So here's the situation. You join a new bank and divide your money several ways, as shown in the circle graph on the right. If you overall invested $55,000, how much money would you have in savings and checking combined? So the idea then is that this circle is representing all of your $55,000. And we're being asked to say how much of that money has gone into checking and savings. So this part right here. Basically, how much money is that? Well, since there are two semicircles and a circle, and that's 180 degrees each, we know a circle altogether contains 360 degrees. So what we can do is, going back to one of our earlier chapters, we can set up a proportion here to figure out how much money we have deposited into those accounts. The way we'll do it is, first, we need to figure out how many degrees are in checking and savings combined. So we'll just take their degree measures, 55 for checking and 105 for savings, and we'll add them together to get 160 degrees. Now we know that that means that there are 160 out of the total 360 degrees in that circle going towards checking and savings. So how do we complete the proportion then? Well, we know that altogether there are $55,000, and that's matching up with the total 360 degrees in the circle, and we are looking for this amount up here. And from there, it's just a matter of cross multiplication. So we'll have 160 times 55,000. That gives us, we have $8,800,000. Well, not dollars. This is an intermediate step. So we've multiplied these two, and now we're going to divide that by 360 to get the amount that is in those two parts. So divided by 360 gives us about $24,444.44. So there you have it. That is approximately how much money has been put into checking and savings. One last thing before you're ready for the assignment. One last theorem that we have. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. What that means is, so let's say that this chord here is the same as this chord here. Or, if you have two separate circles, it could even be that we have another circle the same size as that one, and we have a chord, and we're told that that is the same amount as that one. What that will also mean is that these arcs that are kind of cut off by those chords are also going to be the same size. So, in this example, problem 5, if the measure of TV is 121 degrees, and we're told that ST is 29 degrees, we need to find RV. So we are looking for the one I'm about to label in red. We're looking for that one. Well, what we can do here is, since we know that this is one circle and this length is the same as this length, we also know that this being 121 will also mean this is 121. So we have 121 over here, we have 121 on the other side, we have 29 in between, and we know that RV needs to complete the situation so that they all add up to 360. So we can do 360 minus 121 minus 121 minus 29. That gives us 89, and that's going to be the size of RV. Which also means that if you made an angle going from the center, going to R, and going to V, that angle would also be 89 degrees. That's just a side note. So there you have it. Those are the remaining types of problems that we have from section 2 of chapter 10. Up next will be some information from 10.4. So, see you at the next video.